Good afternoon, everybody. I still remain Timothy. Today we'll be looking at indices, a topic in mathematics, and though I won't be doing much on indices today, I just want to prove the laws of indices, and that's all. In my subsequent videos, I will upload as many examples as possible as I can solve. I'll just upload them. Now, without wasting much of our time, we'll go over to listing some laws of indices. I'll put on the board as many laws as I can remember. If there is a one you know that is not on the board, you can just put it down in the comment box below. So we move. Laws of indices. Laws of indices. Number one law is what a raised to the power m multiplied by a raised to the power n is what a raised to the power m plus n. Now the second one is a raised to the power m multiplied by b raised to the power m is what a multiplied by b all raised to the power m. And the third one is a raised to the power m multiplied by b now divided by b raised to the power m is equals to a divided by b all raised to the power m. The next one is a raised to the power m divided by a raised to the power n is what? A raised to the power m minus n. The next one is a raised to the power 0 is what? 1. The next one is a raised to the power m all raised to the power n is what? A raised to the power n mn. This is for n. The next one is a raised to the power minus m gives us what? 1 all over a raised to the power m. The next one is a raised to the power 1 over m is 1 over n. N is what? The nth root of a. Now the last one I can remember is what? A raised to the power of m over n is what? The nth root of what? A all raised to the power m, which is still equal to the nth root of what? A raised to the power n. Now having listed some laws of indices, I'll go over to proving them. But before I do anything, I would like to restrict my m to be equal to what? 4. My n to be equal to what? 3. My a to be equal to what? 10. And my b to be equal to what? 5. It is not a must. You don't have to do your own like this. You might want to choose any number, it will still work out, because m and n, a and b, they are all dummies. So we'll go back to proof. Now proving 1, we say that a raised to the power m multiplied by a raised to the power n is equals to what? A raised to the power m plus n. Now I say that my m is equals to what? 4, and my n is equals to 3. So that means a raised to the power 4 multiplied by a raised to the power 3 is equal to a raised to the power what? 4 plus 3. Let us check if that is true. A raised to the power 4 simply is a multiplied by itself 4 times. This is a times a times a times a. Now multiplied again by a raised to the power 3, which is a multiplying itself 3 times, which is a times a times a. Now, of course, a raised to the power 4 plus 3 is a raised to the power 7, which is a raised to the power 7. Now, which is a multiplying itself 7 times. Now, a times a times a times a times a times a times a. Looking at this now, we can easily see that they are on the same. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that means that a raised to the power m multiplied by a raised to the power n is actually equal to a raised to the power m plus n. You see, that is the first one, and it is proven. That is the first one, and it is proven. So we go over to the second one. We go back to the second one. A raised to the power m multiplied by b raised to the power m is equals to the second one. A raised to the power m multiplied by b raised to the power m is equals to what? A times b all raised to the power what? M. So now remember that our m is what? 4. So a raised to the power m is what? So that is a raised to the power 4 multiplied by b raised to the power 4 is what? A times b all raised to the power 4. Remember that our a here is what? 10, and our b here is what? 5. So having done that, we'll now say 10 raised to the power 4 multiplied by our b is 5. 5 raised to the power 4 is equals to what? 10 times what? 5 raised to the power 4. So now 10 raised to the power 4 actually is going to give us 10,000 times 5 raised to the power 4 is going to give us what? That's a big number, 625 years. 625. Now, what is 10 times 5 is what? 50, yes. 50, remember, raised to the power 4. Now, multiplying these two is going to give us 625 0 0 0 0, which is 1 2 3 1 2 3. It's going to give us 6,250,000, and I believe that is what this is going to give us. So 50 raised to the power 4, 60 raised to the power 4. What we're going to do now is 50 raised to the power 2 is going to give us what? 50 raised to the power 2 is going to give us 2500. Now 2500 by 2500 again 0 0 0 0 0 0 0 0. Now this gives us 0 0. This is 25. Write 5 carry 2. 10 plus 2 12, and this gives us 0 0 10, and 2 plus 2 is what? 10. Write 0 4 5. So 0 0 0 0 5 2 6. So 1 2 3 1 2 3. So it gives us 76250 0 0 0. So we've seen that it gives us the same thing. Actually, I don't like using calculator because the more I use calculator, the more my brain gets dull. Just like one of my mentors used to say, Arthur Benjamin, he likes using his head more than using a calculator. So I guess you should try that also. So we've seen that actually they are the same. So we'll go back to the next proof. Go back to the next proof, which is a raised to the power m divided by b raised to the power m is equal to what? A divided by b raised to the power m. Now remember, what is our a? Our a is what? 10. This is 10. Now 10 raised to the power 4 divided by 5 raised to the power 4 is what? Our a is what? 10 divided by 5 all raised to the power 4. And 10 raised to the power 4 is going to give us what? 10,000 years. And our that is 5 raised to the power 4 is going to give us what? 25 25 625. Yes, 625. Now this is 10 divided by 5 actually gives us 2. raised to the power 4. Now we go over to division. 10,000 divided by 625 is equals to what? 2 raised to the power 4. Let us see if it is true. 5 can actually, 25 can go. 25 can go. When 25 divide this, it gives 25, right? 25 divides 100 gives 4. Divide this, 400. Yes. 25 divide 100 gives 4. Now 25 into 25 gives us what? 5. 5 into 40 gives 8. So 5 divided 1 divide 80 is what? 16. So actually 16 is equal to what? 16, because 2 raised to the power 4 is what? 16. Having seen that, a raised to the power m divided by b raised to the power m is equal to what? A divided by b all raised to the power m. So they are the same thing. It is proven. We'll go over to the next one, which says a raised to the power m divided by a raised to the power n is equal to a raised to the power m minus what? N. So now remember that our a is what? 10 raised to the power what? 4 divided by what? A is what? 10 raised to the power what? 3 is equal to 10 raised to the power what? 4 minus what? 3. So now 10 raised to the power 4, 10,000 would have been used to it by now. 10,000 divided by what? 10 raised to the power 3 is 1,000. 1,000, which is also 10, 4 minus 1 is what? 4 minus 3 is 1. So no need. Let's just put 1 here. So now, 10,000 divided by 1,000. Actually, this will cancel this, and we'll have this equals to 10 raised to the power 1. So everything now is clear. 10 is equal to what? 10. Because 10 raised to the power 1 is what? 10. So now, having seen that, a raised to the power m divided by a raised to the power n is equals to what? A raised to the power m minus n. So this actually is proven. We'll now go over to the next one, which says a raised to the power 0, sorry, number 5. A raised to the power 0 is equals to 1. Now here, there are some constructions you need to do. And what are the constructions? Remember, we start, okay. We're going to find two numbers that will give us 0. It can be minus a plus a, minus b plus b, any two identical numbers, and when we heat them up together, it's going to give us 0. So now, I know that a raised to the power m minus m is equals to a raised to the power n minus n is equals to a raised to the power what? 0. Do you understand? So now, the next thing I will do here is, I know that a raised to the power m minus m is the same thing as a raised to the power m divided by a raised to the power m. Yes, that is from the third, from the fourth law. So nowadays, I can say this is still equal, okay. A raised to the power m divided by a raised to the power m actually is a all over a all to the power m. When a divides a, we're going to have what? 1 to the power m. And 1 raised to the power 1 million is still 1. 1 raised to the power 1 trillion is still 1. Anything in text 1 is still what? 1. So this will leave us with no choice other than a raised to the power 0 to be equal to 1. I don't know if we understood this one. Please, if there's any correction here, you can drop it in the comment box below. I would like to see some corrections and some thumbs up in this video. I believe this one now is clear. I'll go back to the next one, which says a raised to the power m to the power n is what? A raised to the power m. Sorry, is a raised to the power m n. Now, remember that our m is what? Our m is what? 4. Our n is what? 3. Is what? Is equal to a raised to the power 3 times 4 is equal to a raised to the power what? Sorry, this is 4 times 3. 4 times 3. 3 times 4. And our a is what? 10. 10 raised to the power 4 or raised to the power what? 3 is equal to 10 raised to the power 4 multiplied by 3 is equal to 10 raised to the power 3 multiplied by 4. Now, the next one is 10 raised to the power 4 is 10,000 all raised to the power what? 3 is equal to 10,000 all raised to the power 3 is equal to 1,000 all raised to the power 4. As you can see, we are heading over to very large number. But you believe me that everything here is equal. This is 10 raised to the power 4, this is 10 raised to the power 4, this is 10 raised to the power 4, and this is 10 raised to the power 3. And this is to the power 3, this is to the power 3, and this is to the power 4. So, whichever way they are equal, you can press it out with your calculator to know if it is correct. So, this is proven. So, come over to this one, the 7th one. It says a raised to the power minus m is equal to 1 over what? A raised to the power m. Now, before I say anything on this, I would like us to look at the number line. Here is what the midpoint, and here is the positive 1, 2, 3. Here is minus 1, minus 2, and here is minus what? 3. And here is 0 plus 1 to give us 1, 0 plus 2 to give us 2, and 0 plus 3 to give us 3. That is how it goes. But this other side, 0 minus 1 to give us minus 1, 0 minus 2 to give us minus 2, 0 minus 3 to give us minus 3. That is how it goes. So I'm going to use this here to solve this. So now, here is a raised to the power 0 minus what? M. 0 minus m. And from the fourth rule, we see that this is equal to a raised to the power 0 divided by a raised to the power m. And from the fifth rule, we see that a raised to the power 0 is equal to what? 1. And this is still equal to a raised to the power 0 divided by a raised to the power m. We know that a raised to the power 0 is what? 1. So now, that is how you get 1. Now, a raised to the power 0 over a raised to the power m will now give us 1 all over a raised to the power m. It is simple. I will just do a recap on this one. A raised to the power minus m to give us this. A raised to the power minus m to give us 1 over a raised to the power m. So now, from a number line, you know anything going to the left hand side is just 0 minus that thing. So now, 0 minus m is just equal to what? This. This is still equal to this. So now, from the fourth rule, we now see that we see that a raised to the power m divided by a raised to the power n is what? A raised to the power m minus n. That is what I used here, and I splitted the two of them again, giving them a common base, a raised to the power 0 divided by a raised to the power m. Now, from the fifth rule, we see that a raised to the power 0 is 1, and that is actually the same thing I used here. I don't want to prove it more because it is already proven, and from our common mathematics knowledge, we know that this is still equal to this. So you can write it this way, you can also write it this way, a raised to the power 0 divided by a raised to the power m. So a raised to the power 0 is 1 and a raised to the power m is what? M. And from what we got here, from what we have here, our a is what? Our a is what? Okay. So this is it. So now this is proven. Number 8. The next one, number 8 says a raised to the power 1 over n is equals to the nth root of what? A. Alright. There are some, I would like to prove this one in, okay, let me just go straight forward. We're going to prove using n equal to 1, n equal to 2, n equal to 3. If n is equal to 1, of course, a here, of course, a 1 over 1 is not going to make sense. Let me use n equal to 2. So now, the square root, no. How am I going to say this now so that you will be able to understand what I want to do? Okay, first of all, let's do this. We know that root a times root a is equal to a, right? Yes. And so we further proceed. Put root a equal to what? A raised to the power, let's say r. Why did I do this? Now, you see that this a times a here is actually root a raised to the power 2. So this square root can take care of this to have a. So whichever way, and we know that this is just a raised to the power 1 over 2. No matter whichever way. That's why I put this r here to take care of the power. So the next thing I will do here is root a multiplied by root a is equals to a raised to the power r multiplied by a raised to the power r. Now, there's nothing I want to do. Here, root a times root a, of course, it is root a all raised to the power 2, which means this will take care of this, and this is a raised to the power r 2r. So now, a here is equals to a raised to the power 2r. Remember, a is still the same as a raised to the power 1. So equating the index, I can say that 1 is equals to 2r, which implies that r is equals to what? 1 over 2. So now, we now see that if r is equals to 1 over 2, we can say that a raised to the power r is equals to what? Okay, we can say that the square root of a is what? A raised to the power r, which implies that square root of a is what? A raised to the power 1 over 2. So having done that, this one is proven. That is when n is equal to 2. it actually works when n is equals to 3 and when x is equals to what, 4. The only thing you need to do is just to do some constructions and boom, off you go. So the last one is what? A raised to the power m all over n to be equals to the nth root of what? A all raised to the power m. Now this is very simple because we can actually write it like this: a raised to the power 1 over n m. And from the 8th law, having done this, you can just do this the first time and raise it to the power m, or you can also do it this way: a raised to the power m then 1 over n. Whichever way it is being done, it will still give you the same word answer. So this is being proven and this is being what? Proven. You can just fix in the values and see that they are what? The same thing. So this is what I want to share with you today. If there is any mistake, I would like you to put it down in the comment box. I still remain Research Ebuka Timothy. I would like you to hit up the like button and subscribe. Thank you.